Hello everyone, this is Pure Mathematics Chapter 2. In this video we are going to discuss about section 2.9, which is modeling with exponential functions. So in the previous videos we have seen what is an exponential function and some examples on the exponential function and the equations involving in exponential functions, solving equations that have exponentials. Now we will see some applications using these exponential functions. So some real world examples we'll take and we'll make use of exponential functions and solve those real world problems. Let us see this example. If the population of 100 bacteria doubles every minute, how long does it take to reach 12,800? So the bacteria population is given in the beginning. It is 100. Starting the bacteria is 100. And after that it doubles every time. Doubles means every minute. Doubles every minute means it is multiplied with 2 every time. So starting 100, after 1 minute it is doubled. That is multiplied with 2, 200. Again after another minute, that is second minute, it is again double. That means 400. After that 800. So each time it is doubled. That means we are multiplying with 2 each time. And here we are asked to find how long does it take to reach 12,800. So we have to find the time t when the bacteria number is 12,800. For that we have to write the equation. So this writing the equation is very important. A is the number of bacteria and we have to write it as starting how much you have, 100. You start with 100 the beginning and after that you have to multiply. For each minute you have to multiply with 2. So multiply with 2 each time we are increasing, we can write it as 2 power t. So t equal to 1, that means after 1 minute you multiply with 2 power 1, that is 2. And after second minute we are again double, that means 2 times 2, that is t equal to 2 then. 2 power 2 means 2 times 2. Therefore the equation for this population growth is A is equal to, that is the number of bacteria is equal to 100 times 2 power t, where A is the amount of bacteria or the number of bacteria and t is the time. So when t is increasing and each time t is increased by 1, we have to multiply with 2. That's why the equation is A equal to 100 times 2 power t, where 100 is the starting population of the bacteria. Here we have to find time when the bacteria reaches 12,800. That means A is given. Here A is given as 12,800. So here A equal to 12,800. So we have to find the value of t. At what time it reaches 12,800. So if you put A equal to 12,800 on the left hand side of this equation, 12,800 is equal to 100 times 2 power t. Now cancelling 100 both sides, 128 is equal to 2 power t. Now the right hand side 2 power t is there. So left hand side 128 also we try to write as a power of 2. And we observe 128 is 2 power 7. 2 power 7 is 128. Therefore 2 power 7 is equal to 2 power t. So both left hand side and right hand side are exponentials with the same base, 2 here, 2 here. So we can equate the powers. Therefore t is equal to 7. Here power is 7, here power is t. So t equal to 7. So what we get from this? After 7 minutes the bacteria will reach 12,800. So the answer is 7 minutes. After how much time it will reach this population? After 7 minutes the bacteria population reaches 12,800. So here the main point is forming this equation. The amount of bacteria A is equal to 100 times 2 power t, where 100 is the starting population of the bacteria. Why we are writing 2 power t? Because it is doubling each time it increases by 1 minute. So here the time is given in minutes, and each time it is doubling means 2 power t we write. If it triples each minute, then we have to write a is equal to 100 times 3 power t. If it is triples means multiply with 3 each time, then the equation would be a equal to 100 times 3 power t. Like that, based on the question, we have to form the equation and solve for t. So this is all about this example of using exponential equation to solve a real world example, a real world problem. Let us go to the next one. This example, let us read it. A total of 12,000 Omni Real is invested at an annual rate of 9%. So some investment is made. We are making 12,000 Omni Reals, and the rate of interest is 9%. 9% is nothing but 9 by 100. And find the balance after 5 years if it is compounded continuously. So if we keep an investment of 12,000 for 5 years and with the rate of interest as 9%, what is the amount after 5 years we have to find. So this is the formula for compound interest and the amount. So A equal to P times e power RT. You have to remember this formula, where A is the amount and P is the principal. Principal means the amount we put for the investment. And E is a special number, which is an irrational number, E. And we have seen before, E value is 2.718 up to 3 decimal places. And R is the rate of interest here. R is 9%, which is 9 by 100. And T is the time. Time is given as 5 years. So substituting these values in this equation, A equal to P times e power RT is the equation, which gives the amount after t time with the rate of interest R and with the principal P. So how much is invested here? 12,000. So the principal P is equal to 12,000, the starting amount we invested. And R is given as 9%. The rate of interest, 9% is nothing but 9 by 100. And the time T is given as 5 years. So T is 5. So after getting this P, R and T, let us put in this equation. A is equal to P value 12,000, e power R is 9 by 100 times T is 5. So 9 by 100 is nothing but 0.09. Multiply with 5. This is in the power. So 12,000 times e power 0.09 times 5. Using calculator, we can observe that this value is 18,819.746. So this is the amount we will get after 5 years if we make an investment of 12,000 and at the rate 9% per annum. So this is one more application on to find the amount after a certain period of time with some rate of interest. We have one more example here. So the number of computers infected by a computer virus increases according to Vt is equal to 100 times 4 e power 4.6052 t, where t is the time in hours. Then find the initial number of infected computers at V1 after 1 hour, at V1.5, that means after 1.5 hours. These three questions are there. So if you see this equation involving exponential function, and Vt is the number of virus at time t. So here t is the independent variable. You can take on x-axis because the independent variable we take as x. Here the independent variable is t. So t is on x-axis. And Vt, V is the dependent variable. So dependent variable we generally take on y-axis. What is the dependent variable? Vt. So the amount of bacteria depends on time t. For different times you will get different bacteria. And we are given this equation. Vt is equal to 100 times e power 4.6052 t. So by putting t values that is different times, you can find the population of bacteria, that is V. So if you look at the question, the initial number of infected computers is asked. Initially means when the time is 0. Initial means in the beginning. That means you have to put t equal to 0. When time is 0, how many computers are infected? That is V we have to find when t equal to 0. So let us put for the first option A, the initial number of computers. If you want, we have to put t equal to 0. Time is 0. Initial means time is 0. So if you put t equal to 0 in this equation, V of 0 is equal to 100 times e power 4.6052 times 0. So 0 times any value is 0. So you will get e power 0. And e power 0 is 1. Always any value power 0 is 1. Therefore 100 times 1, that is 100. That is when time is 0, the number of computers infected with the virus is 100. So when time t is 0, the infected computers number is 100. Now the second option, the second question we have, at V1, what is the value after 1 hour? After 1 hour means you have to put t equal to 1. So if you put t equal to 1 in this, you will find the bacteria number after 1 hour. So by putting t equal to 1, you will get V1 is equal to 100 times e power 4.6052 times 1. In place of t, put 1. And if you use calculator, the value of this will be 10,000, nearly 10,000, which is approximately 10,000. And similarly, the next one, C question at V1.5, that means after 1.5 hours, what is the number of bacteria infected? So we have to substitute t equal to 1.5 in this equation. If you put t equal to 1.5, V 1.5 is equal to, here it is written as 1, no it's wrong, it is 1.5 here, V 1.5, because we are putting t is 1.5. V 1.5 equal to 100 times e power 4.6052 times 1.5. Simply in place of t, we are putting 1.5. And if we simplify and find this value using calculator, 100 times e power 6.90578. So multiplication of these two gives 6.9078. After that, exponential of e power 6.9078 multiplied with 100 gives this number, which is ones, tens, hundreds, thousands, 10,000, 100,000. So this is 100,004. This is approximately the number of bacteria that are infected. So this is how we make use of the exponential functions to solve some real world examples. Here there are three problems in the exercise. You can try to do similarly. Here the first problem is about the compound interest. Here the amount invested initially is 7,500 and rate of interest is 6%. So R is 6 by 100. 6% is 6 by 100, and amount P, principal, initially P is 7,500 and number of years is 10. So using this information you can find A, that is the amount we will get after 10 years if we invest 7,500 for at the rate of 6%. Similarly, there is another problem on exponential function, and the population of rabbits is the question here. You can try to do the same way. Using this information, you can find the population of rabbit R is given by 50 times 1.07 power n, where n is the number of weeks. So when number of weeks is increasing, the population of rabbits, that is R, is also increasing. So using this equation, you can answer these ABCD, the questions ABCD for this. Similarly, you can do this problem in the exercise using the same concept. So this is the end of this presentation.